Alright, logs number 5. This is solving exponential equations. The key part of this is to get alike bases. And you can only go smaller, you cannot go larger. Meaning I want to make them into 2s and 3s and 5s. The prime numbers are the way to go. You don't want to go to 4s and 9s. If you have 4s and 9s, you want to go farther to 3s and 2s. So let's start with 4 to the 3x is equal to 8 to the x plus 1. So the key part here is recognizing the bases are made of the same number 2. 4 is 2 squared, and 8 is 2 cubed. Now when we have power to power, so here we have like base, put them into the like base, simplify exponents if necessary. Since the bases are alike and equal, so are the exponents. The whole purpose of getting like bases is so that we can set the exponents equal to one another. And then you can just solve this. 3x equals 1, so x equals 1/3. Okay, let's try 1/2 to the 4x equals 32 to the x minus 1. So the first thing you need to ask yourself is, what base is 1/2 and 32? And you should come up with the answer of 2. How does 1/2 become 2 if the exponent's a -1? How does 2 become 32 if the exponent is 5? Simplify your exponents if necessary. Now that the bases are equal, so are the exponents. And solve. But the key part is getting those bases alike. Once the bases are alike, then we get to move forward. So let's try one more of those. 9 to the 2x is 1 over 81 to the 3x minus 1. So we need to recognize 9 and 81 is made of 3's. How do I get 9 using a 3? I square it. How do I get 1 over 81 as a 3? It's to the -4. Simplify my exponents. And solve. But the key part is knowing how to get those bases alike. Now sometimes we can't get bases alike, and there's nothing we can do about it. For example, 2x is 7. There is absolutely zero chance that 2 is going to give me 7, 7 is going to give me a 2. So when bases are not alike or cannot be made alike, we're going to use logs. Okay, so exponential form. So in order to use logs means we have to change it to log forms. Log base 2, because the base of the exponent and the base of the log have to be the same, of the number is the exponent. Because remember, if I change it, it's got to come out to be the same thing. The 2 would kick up the x. Okay. Now, I still don't know how to do this. I don't know log 2 and 7. And my calculator is only in log base 10. So I've got to somehow be able to change this. And we call this the change of base formula. And what it is we take the log of the number over the log of the base. Okay, so in this case, log of the number over log of the base. You're also going to hear this as calculator ready form. So calculator ready, this is calculator ready. Because once I change this to log of number over divide by log of base, if I don't have the log there, that's implied to be 10. And if it's implied to be 10, I get to use my calculator. And that is what we're going to be doing. If we cannot change things into like bases, we need to change them into like logs, meaning log base 10. And we get to do that by changing it to our calculator ready form, and then we plug it in. So here we're going to have log, L-O-G, of 7. Make sure to close the parenthesis. That's the biggest mistake, as we forget to close it. Divide log of 2. And you can hit enter, and you get your value 2.807. And go to 4 significant digits. So there's 1, 2, 3, 4 significant digits. All right, so here I have 10 to the 2x plus 3 is 8. Well, first of all, I have to try to get the exponent as alone as possible. So I'm going to subtract it. I get 10 to the 2x is 5. Even though it looks like 10 and 5 are related, yes they are, but they are not bases of each other. So I cannot do anything but change it to log base 10 of 5 is 2x, and then divide by the 2. This I get to put in the calculator because my calculator is already in base of 10, so I don't have to do calculator ready form. I can just do log 5 divide by 2. And when you punch that in your calculator, you should get 0.3495. Let's try again. 10 to the 2x minus 3 plus 4 is 21. So the first thing we want to do is get rid of that extra part of the 4, and that becomes 17. Now I have to get to my exponent, which means change it to log form. Now my calculator is already in base 10, so I don't need to change it to calculator ready form, but I do have to solve for my x. So log 17, I'm going to add 3 and divide by 2, right? Add the 3 and then divide by 2, and I get to punch that in the calculator. So when I do that, I get log 17, close your parenthesis, plus 3, divide by 2. 2.115. Now, if you did not get this answer, did you go plus 3 and then divide sign 2? Check that, because if you did, your calculator only divided the 3 by 2, and that's not right. It has to be the whole thing is divided by 2. So watch your parentheses. Alright, the same thing works for the e, or the natural log. If I have 40e to the 0.6x is 240, in order to get to the e, I have to get rid of the 40. So I'm going to divide both sides by that. So I get 6. Now I have to change it to log form, and e is automatically a natural log of the number is the exponent. And then divide by the 0.6. Punch that into your calculator. Natural log of 6, make sure to close your parenthesis, divided by 0.6. Give me 4 significant digits, so 2.986. All right, one more. 4 minus 2e to the x. First of all, we're going to subtract the subtract the 4, so negative 2ex is negative 27. Then we're going to divide by the negative 2, so we're going to get 27 halves. When I change it to log form, I get x is the natural log of 27 halves. I can leave it just like that. I don't need to expand it out. I can just type in the natural log of 27 halves. And then 4 significant digits, 2.603. Make sure we're rounding correctly and completely. So 2 things are part of log number 5. Make sure that we can change things to the like basis. And if we can't get a like basis, that we need to use our log transformation and possibly a calculator ready form.